The emperor have no clothes, but I put my shirt on today. Well, it's really my pleasure. I have been talking about CSPP, and we have talked about CSPP thousands of times during this meeting. But we are not tired of it because we're going to continue to push forward to support you in any way you see fit to use CSPP as much as you can, and we will provide all the service support as much as we can, of course, under the big umbrella of we are supporting NOAA's mission. Okay, NOAA is our sponsor, and we are responsible to promote what their mission is all about. So hopefully CSPP can contribute very small portion of it, engaging with all of you, and together we support NOAA, and everybody benefit from it. So it's continue NOAA goal of sharing meteorological satellite data processing software, actively supporting the community. Community is everything, okay? It's part is you. So we have 40 years of this type of experience that Bill Smith started out, the father of satellite community processing package, so to speak, and it started with 1982. Okay. Some of you was maybe not born yet, but anyway, the father of the processing package, Professor William Smith, started the first NOAA infrared microwave sounding retrieval software. Originally, it's just for the sounders, science, because the barrier of entry is very high at the time. So providing the global user this type of capability is really able to help people to use it more often and innovate around it. At the time, it's called HIRS, HIRS, High Resolution Infrared Sounder Microwave Sounding Units. In 1999, we advanced to the next generation called Advanced ATOPS, Advanced TOPS Package, International ATOPS, IAPP. And we are supporting it still. This is the second generation of NOAA retrievals, and then the second version of sensor MSU. MSU is Advanced Microwave Sounding Units built by the UK, and HIRS-2, the second generation, 2000. Okay, we work with NASA because at the time they had the first LEO hyperspectral sounder in a research a type of missions, Aqua. Okay, the satellite Aqua. So with International Motors Air Processing Package, that Kathy take a strong leadership for many, many years, and we do workshops, motors, airs around the world. We go to South Africa, we go to Norway, Tromsø, a very cold area inside the Arctic Circle. Okay, so motors air processing called IMAP is the first NASA hyperspectral sounding imaging processing package, including motors, the precursor of VIIRS. And 2012, with encouragements and conceived by, guess what? Mitch Goldberg at the time is the lead scientist of NOAA, our dear friend Mitch Goldberg. Thank you, Mitch, that he invented the name, Community Satellite Processing Package. Thank you, Mitch. It's a nice name. It's very impressive. Talk about the open-mindedness of Mitch. Okay, that's what it's all about. Community. We want to work with you. So we have first NOAA JPSS program, the processing package, including VIIRS, CRIS, ATMS, YACI later on. That's the hyperspectral version from METOP, ABC. Now we have BC running, and the MERCI, the Chinese API, our geo components, AHI, the Japanese JMA component. We do have processing package supporting AHI too, and some of the tools, very powerful tool, and of course the legacy imager AVHR. So IAPP, we're still supporting it, believe me or not. We still have 154 users in 26 countries as of June 6. IMAP is discontinued funding from NASA. We have about 14 years of funding or 16 years funding since early 2000, right? Yeah. So we are very proud of that, but they're trying to discontinue it because they are not that a high priority anymore. But still, 3,000 users in 105 countries. CSPP real. We have close to 3,000 in 107 countries as of June 6. So hopefully next time around we have more countries participating. Hopefully maybe NOAA is generous enough, such as programs, Indies program, Mitch's program, maybe you can sponsor some of the users to come over here to join us. There's some of them, they are just not able to participate because of the constraint of their agency fundings. Maybe we should supporting them, some of them, to participate. And so everybody will benefit from it and grow continuously. Oh, okay. I want to trace back to history. I'm talking about history, my favorite topic. But actually, history is not my topic. When I have a history class, I always nearly a passing grade. I don't want to memorize everything, historical. So the first proposal that conceived CSPP is at 2012, 13. I think Kathy and Lim wrote majority part of the proposal. I'm just innovators. I'm just talking. They do all the work. Coming out with good proposal, who should do what. But anyway, it's the idea of what is supporting real time. So that's very critical. Low latency with CSPP play a vital role so that we enable the low latency processing. When they get the data, they quickly process and turn into product they can use in low latency. For example, NWP, Sasha talked about their low latency use of the data in NWP, very critical, and direct broadcast, especially also pre-processing to SDR is part of efforts so that I can reduce the latency, that give them the cutoff time enough to use more data. That's quite critical. So we emphasize the real time, and of course it's regional because its direct broadcast will be regional. So we have community in mind. We adapt the community radiation transfer model. There is another successful program conceived from NOAA side called CRTM. Similar community. And we want to support both polar and geostationary satellite. It's global. Even the geo rings, some are regional. But we have that global in mind, community in mind. We adopt a successful practice already exists. And we emphasize real time. We emphasize all users. Okay, all users. Okay, now this is Lim's chart actually that he put up. He said, what should we do? And Lim says, let's do this. That's his grandeur list of what we need to do. And guess what? Majority are still pretty correct, pretty mature at the time, is showing his breadth and depth of knowledge and forward thinking. Okay, so I don't want to get into detail. We need to have ancillary all the data, auxiliary data automatically, so users don't have to go there and get this and get that. And we have staging those necessary data and have a backup more so that you can worry-free to run the data. But we have historical processing, a little bit of issues because we cannot keep up with the historical and ancillary data required for processing historical data. So that part, maybe we need to continue to see a better way to do it. Maybe we should have a long-term archive for all auxiliary data in somewhere, and so automatically they will recognize I need to use the 5 years ago ancillary data and it's automatically graded. But I don't know, you guys have a better technology than me. I'm just a simple algorithm, simple chain of algorithm, chaining. Okay, you don't have to run this and then output out and then run this. It's all chained together, easy. Provide products optimized for NWS, National Weather Service, which is using a very, I cannot say strict, it's very unique AWIPS systems. So we want our product able to flow into their AWIPS system. They have so little time to digest the data and use the data. If we don't get it into their system, they cannot use it. They cannot take advantage of it. So that's also a very important concept that we want to do. And I think we're achieving it. Okay, the new CAPS sounding data is the best testimony that Nadia is promoting, Scott is promoting. That's the best testimony of what we are doing. And the last one I want to mention is in GPU. At the time, we talk about latency is important. At the time, let's use GPU. But LIM have better solutions, so they have a low latency solution coming up without using GPU. Is that right? Or using GPU? We will hear the story. So latency is all 12, 13 years ago. We already have that mindset. So we are pretty forward thinking, okay? All right, March 14, 2012 is our first public release. Thank you, Kathy. Without her approval, we cannot release. So you have to thank Kathy, okay? If any problem, that's her fault too. No, I'm just joking. We have 88 software released so far, and the release component of it, okay? So every single years, we work very hard to get adopted that Huang sensor based algorithm to quickly make it available to all of you. And we consider that is validated NOAA benchmark official best product algorithm that can produce. So rest can be assured that you will get the best high quality products because of NOAA support, because of our efforts together, okay? All right, this is my chart. Now the best chart is a scientist chart, my own chart. I like it, but people don't like it. It's just so complicated. But it's really talk about the end-to-end part of it. So this chart is very complicated, by any means incomplete, okay? And all the technical detail, Lim and Graham will talk about it, so I don't want to take care of it. It's just overarching charts. So I want to come with the satellite parts, okay? We have satellite, we have through direct broadcast, all other means you get the data from class of this SMPP, NOAA 20 others, Terra Agua, Terra have models on Agua and Terra, AIRS on Agua, METAP ABC, A is Sunset, BC, that including MSU and ERC, FY3C, 3D, we have certain processing of images, goes 15, 16, 17, the APIs, Himawari, AHIs, and then we will get turned into SDR processing, level 1 processing. We do a calibration, navigation, all those sensor data. So you can start with there, have the best SDR that go into the NWP, go into a data separation, go into your own algorithm processing as you see fit. You can stop there. You don't have to go continue, okay? And then you want further ambitious, you want to get products. We have a lot of RGB product, cloud product, profile, trace cases, LS, SSD, and also DAS5, flash, and etc., etc. And we go one step further. For example, we have a program called infusion data into environmental application. We infuse ozons, we infuse other model data so that we can do air quality forecast. IDEA international version of it is one of the classical example extended to level 3. At one time, we had forecast model, Sims homegrown DB crash model, using models outputs to do forecast. And then you can model that, but that was not supported anymore. So, and then we have other usage applications. So, application part, we give you some sort of examples that you can take it further up by using level 2 or level 1, okay? So we have many software packages. So we really appreciate the unsung hero behind CSPP. We are the beneficiary of those algorithm developers that take their lifelong career develop its best algorithm, best model. CleverX, the former developer. No, I want to see developer of CleverX is still here. You should not consider yourself as a former developer. Andy, you're still a developer. We want you to continue to work on it and accelerate and improving CleverX. So you cannot go away, okay? You are not formal. Profiles, trace case is very famous, new caps. High resolution retrieval is a homegrown retrieval, not NOAA validated retrieval, but offer another alternative. Okay, you can high spatial resolution retrievals in single footprints because new cap is doing calculating with 3x3 coarser spatial resolution. For regional use, you want highest possible resolution. We have that as well. MEAS microwave, such as your microwave that's already heavily used, precipitation, soil moistures, all those cloud hydromedias, is all there, ice, sea ice, ASPO, all the SSTs in one package. One package able to give you all different sensors SST consistently. Beautiful SST, high quality, half degree accuracy, that kind of performance. Flat, Mitch is touting the flats used by the journalists and some of the high level summit as an example, flat, okay? And fire, and then the legacy IAPP, and then the geosite, I'm sorry, the Graham that you can talk more about it, GeoCat and others. Okay, but we don't stop there, it's just producing products. We want to give you better tools. What is better tool? We have other tools. Okay, visualizations, mapping, projection, polar to grid. Some people use that for operational official transformation of rich information, rich product into a very pleasing, visualizing, colorful images, animations. And we are going to, someone is going to talk about it, maybe Dave. And then we have visualization systems that we use, that Paul Menzel mentioned. We use Hydra as a teaching tool, as a workshop. So we developed specific for user to interrogate the data or all the above I mentioned using Hydra at the classroom. We teach in the morning how to use those data, how the theory of retrieving the data, and then in the afternoon using Hydra to interrogate themselves, to see for themselves. And then we have Real Earth. It's a powerful open source visualization system that everything you want to integrate, you can integrate, put 100-layer information. Of course, it will be blinded overlap. So it's possible to have that capability in your own hands using its open source. Okay, go without saying, we through the management of NOAA Direct Broadcast Network, reduce the network, reduce the latency so that everybody can get anyone else within the light circle within fingertips, within milliseconds. So you can have large area, not only your own territory. And we thank Orbital System providing the most reliable system. And we can more pleased that they cannot go away because they cannot sold and to someone else. Don't build that orbital system, X-band, L-band, and S-band system. Okay, you need to be helping us continue to innovate your technology. But thank you, Orbital System, for providing the capability. For a degree, I don't want to say anything more. It's a user-friendly visualization tool. It's very important. The most important part is the workhorse to creating the AWIPS compatible data, so that when we create this after running for a degree, it's already in their screens because automatically, so they can use it because they only 2 or 3 minutes using the data. Okay, that's very beautiful. Okay, Python, that's I don't understand. GeoTIFF, HDF5, it's too complicated for me. Okay, we support many level 3 data, and so the new caps, SSD, microwave, all those important cloud information. Okay. Okay, this is an example. The protocol can create stitches, a very clever way of seamlessly getting all this polar orbiting satellite data is only granular path, and then all can stitch together. And then Real Earth have this similar capability as well. And the most important part, we offer workshops. The barrier to the entry of using this type of data, this type of tool, is pretty high. Okay? If I'm not trained in remote sensing satellites, I will say, wow, that's just 0101, don't mean anything. So can we do that? So we promote local use of satellite data by providing lectures, hand-on, okay? We've been doing this many, and Kathy taught many workshops and be friends with all those people, and it's very rewarding for us. So we have done more than 20 workshops, right? 6 continents, okay, from 60 countries. That's the number from Kathy, I think. So we have done this, just a list, grandeur list, and we are devoted and committed to go to your place to do this type of workshop if you invited us, okay? And we will at our own cost. It won't be at your cost. You provide facility. We will pay ourselves to do the workshop, of course, given the NOAA supporting us. We have been done this Indonesia. This is the North. Last time we were in Mexico with Alejandro. And thank you for your hospitality. We enjoy so much. The Mexican food is delicious. Okay, we have this type of workshop meetings, biennial, every 2 years. We want to do more often. So please invite us to your site. With maybe 2024, we do another one. We won't be doing in medicine. We want to do elsewhere, your site. So invite us, there's the opportunity. So the future. CSPP Sander algorithm is the HIP algorithm, new caps. I don't want to go into the detail. And then the software is homegrown high-resolution sounders. And then Mears sounders. So the future is we want to have this sounder. Right now it's only 930, 130 orbits. Now we might have 530 orbits. Well, we will have 530 orbits. Okay, operated by FY3E. Okay, 530. So they have a question in the Slido about the FY3E. According to Deputy Director General of Satellite Centers of CMA, July 2022, you have certain processing software, maybe just level 1. I don't know the detail, but they promised July 30 in slide 23 of his presentation. It's up there, okay? So the beauty of this is you could get the sounding like I mentioned. New caps, HIPs, HSRTV will continue to 5:30 early morning. You see that 5:30? That 5:30 at a significant coverage within this 24-hour diurnal cycles. What we will have microwave humidity sounder, microwave temperature sounder, high-RAS, high-resolution version of infrared, thousands of channels. This is just the coverage of all the footprints, okay? And you see, if we have, I have plenty of time, 5 minutes, I thought I have 5 seconds. Okay, we will have METAP A 930, impulse 130, and early morning orbits. So see that? We have greater coverage, less gaps. All the interview center was hungry for more data because they have a gap. A data simulation cannot do the work if there's significant gap during the day. So they can capture this high temporal resolution, high spatial resolution phenomenon because the gaps provided. And Saja showed a chart that the sounder have highest impacts. The infrared, the microwave highest impact. That's exactly all this. So this will be tremendously improving, enhancing our capability of covering that. And it's all about quality of the data. If the data quality is not that great, then you suffer the impact, positive impact. So high-RAS FY3D is in red curve. Okay, that's pretty high. Okay, that's NEDN. Okay, NEDT. Okay, 280. Okay, reference temperature. You're using that, but you can see 3E is significantly lower. That's magenta color from especially the show website. Okay, the show website here from red to here magenta, and the mid wave and long wave infrared is original like this, and it's very close to the class of CRIS. And CRIS is incredible sensor. Look at that. It's 0.1, 0.2 NEDT. That's incredible sensor. That's why you can contribute much of the positive impact towards NWP, because if you have anything above 1 degree, you are not able to provide any impact. So we are shooting for high quality stuff, and congratulations to CMA. They make huge improvements from 3D to 3E, and this quality of data coming, okay? All right, lots of data, okay? Lots of data we already try out. Besides, CMA is working on releasing processing package. We are working on not duplicating, just using existing new CAP infrastructure. So we provide CRIS and ERC 930, 130, and 12 hours later soundings. We want to provide 530 sounding information just using the same algorithm. We're working with the new CAP development team from Bonnie, your company, I forgot your company name. STC, thank you. How will kill me. Yeah. We, along with working with the STC scientists, they are the keeper, developer of new caps, so that we can deliver the same high quality, consistent quality of high-res plus microwave sounding similar to ERC and CRIS. And a lot of data, okay, some of the details. But anyway, in summary, I consider CFCC is an excellent framework for community collaboration. Okay, we want to collaborate with you. We want to make sure it's broad and effective use of the data. Okay, and we enable real-time regional users. So contribute to NOAA. So we have to continue to support NOAA mission. Otherwise, we can just do whatever we like to do. Okay, we are supporting their accurate, reliable data and sustained and integrated Earth observing system provide critical support for NOAA mission. When fails, always ask to put this statement in a proposal. We are meeting, supporting mission of NOAA's mission, so this is our mandate, and fully embrace that, fully in support of that, so that they understand we are not just want to do what we want to do, where we are supporting the mission. So, this is a more important sentence. CSP user like you can be sure that now and in the future, your investment, you invest time and efforts will be long-lasting and rewarding. Thank you so much.